Our last conic section in section 10.3 now is the hyperbola. And the definition of a hyperbola is going to be the set of all points on a plane for which the absolute value of the difference between the distance between two fixed points of the foci is constant. So we've got our 2 points here that are our foci. You can see those difference of these distances is supposed to be constant, not their sum, their difference. So it's shorter here because you would be subtracting and it is out there. All right. Those are the foci. The midpoint of the segment between the foci is the center. So you look at the segment between them. That midpoint is the center of the hyperbola. The center of the hyperbola is outside or in between the two curves. In the figures above, the center is the origin, 0, 0, and the points F1 and F2 are the foci, as we mentioned. We also have our segment, but that goes between V1 and V2, which are the vertices here, called the transverse axis between those 2 points that are the vertices. In this particular graph, the transverse axis is horizontal. These two are opening to the side. The transverse axis could also be vertical if they open upward. The conjugate axis is the other axis that goes in the other direction here. And if you think about this like we thought about our ellipses in the last section, we would have thought about our major axis and our minor axis. They're renamed here as our transverse axis and our conjugate axis. For an ellipse, we would find these 4 points and we would draw between them. For the hyperbola instead, we kind of create this box that goes straight across where the conjugate and transverse axes would form straight lines. And then we use the diagonals of those box corners here as the asymptotes, the oblique or slant asymptotes for this function. So we have our asymptotes at y equals negative b over a and y equals positive b over a. If the transverse axis flips to vertical, then we'll be using a over b instead of b over a if it's pointing upward. Okay, so sorry about my paper being in the wrong spot there. Apologize. I'm about to flip my page right here and talk about this in terms of the equations. All right, so here we have the equations of a hyperbola centered at the origin. So we always start talking about the origin as our center. And if our transverse axis is horizontal, the equation will be written in the form x squared over a squared minus y squared over b squared equals 1. Pretty similar to an ellipse, but it's a subtraction instead of an addition. So what makes this one horizontal is that the x value is the one that is positive. If your transverse axis is going to be vertical, it's the y value that's going to be the positive. In a vertical transverse axis situation, I meant to say horizontal, I was talking about the horizontal case. In the horizontal case, we are going to find the vertices by going the a distance, the distance that is underneath x. A squared is underneath x, so we go distance a, left and right. So we'll end with vertices at negative a and positive a for our 2 vertices. And we will have our distance under y, these b points up here, to show us where that conjugate axis is. And we'd be able to draw in our asymptotes based on the corners of those boxes. Then the foci are at c, again in the x direction here for horizontal, where c squared is equal to a squared plus b squared. In the vertical situation, the only difference is that we're going to go in the vertical direction with our a value. So instead of it being part of the x coordinate, which it is for horizontal, it's our y coordinate, of course, for vertical. Same thing for z. Instead of left to right, we're going to go up to down. One more quick little note about this. The asymptotes didn't get restated, so I'm just going to put them in this box right here. So we have asymptotes at y equals plus and minus b over a, and we also had asymptotes at y equals both positive and negative a over b. If you think about slope, slope is rise over run. So if your horizontal transverse axis, the value for y in terms of its height is the b value, that would be our rise. The value under x is the a value, that would be our run. I didn't write the x, I don't know. Sorry, it's a slope times x for a line here. And then the same thing down here, slope times x, missed the x in accident. But the a value is on top for this one because that's the value underneath y, that is the rise. And the b value is the run. Okay? All right. Let's take a look at the first example where my goal is to write the equation of a hyperbola who has vertices at 0, -4, and 0, 4. That's affecting the y coordinate. So right off the bat, I can tell that I'm going to have a vertical transverse axis. And foci at 0, -6, and +6. So my a value here is going to be 4. 4 is the distance up and down that we went to find the vertices. And the c value is going to be 6, the distance up and down I went to get to the foci. From these, I can calculate the b value. I need to know both the a and b values to write my equation. C squared, so 6 squared, is equal to a squared, 4 squared, plus b squared. So 36 equals 16, plus b squared, we've got 20 for our b squared. So the square root of 20 is b, that's 4 times 5. So square root of 4 is 2. 2 square root of 5 is going to be b. The equation then will be, since the axis needs to be vertical, will be y squared over the vertical distance, which was 4 squared. So we'll make that over 16. 4 squared is 16. Minus x squared over. Our b value is 2 square root of 5 or square root of 20. When I square that, I get back to 20. So over 20 here equals 1. So that's the equation of this hyperbola. And you can graph that if you wanted to and check that it had its vertices and foci in the correct place. All right, let's look at the next one. Now we have an equation of a hyperbola here, and we want to find its vertices, foci, and its asymptotes and graph it. All right, so I've got 9x squared minus 16y squared equals 144. I know the first thing I'm going to need to do is get a 1 on this side because I do need to be equal to 1 in my final form of the equation. So I'm going to divide everything by 144. I'm going to go ahead and distribute that on the left side. So that gives us 9 over 144. If you divide those both by 9, 144 divided by 9 is 16. And then divide these both by 16. 144 divided by 16 is 9. Oops, forgot the square there. So x squared minus 16, x squared over 16 minus y squared over 9 equals 1. Positive x squared, which means I'm going to have a horizontal transverse axis. With a value of 4 and b value 3. And I can list the center, the vertices, and the foci. The center for this one is 0, 0. I've got no left-right shifts to my x or y variables. The foci are going to shift along the horizontal axis 4 units. So it's going to be 4, 0 and -4, 0. Oh, I'm sorry. That is not the foci. That is the vertices. I gotta pay a little bit of attention here. I apologize. That should have been the vertices. I have not found C, so I don't know the foci. I was getting ahead of myself. Those are the vertices. I still need those. I need to label them correctly. Those are the vertices. Then I need to find the foci. Vertices, foci, and then the asymptotes. So let's go ahead and find our C value. C squared equals 4 squared, that's 16, plus 3 squared is 9. That's 25. So my C value is 5. And my foci, again, go along the horizontal axis. So they're going to be at 5, 0, and at negative 5, 0. And the asymptotes. You think about your slope here, your rise over your run. So the B value, which was 3, is underneath Y. It's going to be 3 over 4 for X. And also negative 3 over 4 times X. Okay, so let's graph our hyperbola. Center 0, 0. Vertices at 4, 0, and negative 4, 0. The foci are at 5 and negative 5. And in order to graph the asymptotes, I want to graph the conjugate axis as well. The conjugate axis had length 3 up, 3 down. So if I box in my transverse and conjugate axes, should give me a quick way of graphing our asymptotes, just through the corners of these. Graphing through the corner of my box. Should be our line. This one I'm drawing the negative slope one first. It should be the line y equals negative 4/3. It is. Down 3 over 4 puts you at this point. Down 3 over 4 puts you at this point. Down 3 over 4 would put you somewhere over here. 1, 2, 3, 1, 2, 3, 4 would put you right here. So I've gotten the correct points right there. But fast way to graph it is through the corners of my boxes here. I can also just use slope and intercept to get this line drawn. And again, I can see up 3 over 4, up 3 over 4, up 3 over 4. That's my line with slope positive 3/4. Okay, so I've graphed my center, my vertices, my foci. I've used my conjugate and transverse axes to help me draw my asymptotes, or I could have just drawn them with slope and intercept. That works too. And we're going to go from our vertex up towards the asymptotes on both sides right here. Get close to the asymptote, never cross, never touch. So that's my right-hand side. We're going to try to do the same thing over here. And we've got our graph of our hyperbola. I'm going to check this one, take a look at the graph on Desmos, make sure it matches up with what we did. The original equation here was 9x squared minus 16y squared equals 144. I'm going to label a few features on here. 0, 0, that was our center. We had our vertices at 4, 0, and negative 4, 0. We had our foci at 5, 0, and negative 5, 0. Those are all lining up great. And we had our asymptotes at y equals 3/4 x and y equals negative 3/4 x. I'm going to dot those, change their color just because they're asymptotes here. No, I don't actually. There we go. There. And that's the graph for my hyperbola. Should match up with what I was seeing on my by hand graph. Okay. Take a look at the next page. Now we're looking at a hyperbola where their center is not at the origin. We've got some other center HK. I can think about this as a shift left or right by units HK or H and up and down units K. So I'm now centered at HK. Again, if my transverse axis is going to be horizontal, that's because the X coordinate is the one that is positive. I can't really see the plus in there. That's the one that is positive. And if your transverse axis is vertical, that's because the Y coordinate is the one that is positive. What we should expect to have happen here is the same that we saw before. We know that our vertices are going to shift in the direction of the variable that is positive by the number underneath them. So if a squared is underneath, they're going to shift a in the x direction. And starting from h, you're just going to go up a and down a. K stays the same, center at HK. If you were to find your conjugate axis, it would just go from the center up B and down B. The asymptotes right here, again, remember that our formula for asymptotes was y equals b over a times x. This just has the shift up, down, shift left, right. Let's just think of that as a transformation of the line, shifted left, right, or up, down. And so that's going to be the new equation for the asymptote with the center at HK. Foci, same business. We're shifting C units along the horizontal axis, or if it's along the vertical axis, you'd be adding to the Y coordinate instead of the X coordinate. Okay. All right. So we've got a graph right here, or an equation right here that we need to graph, find the center, vertices, foci, and asymptotes. So we're going to do some of our work on this page. It's going to continue on to the back. I'm going to start by regrouping this so I can put all of our y's together. So I've got myself a 4y squared and a 24y. So I'm going to move those to the front. 4y squared plus 24y. And I have a negative x squared and a 4x term. And then the 28, which we'll want to move to the other side. So I'll subtract that off and make it a negative 28. We're going to complete the square. When we do that, we're going to have to factor first. So let's factor out the coefficient 4. That'll be 4 times y squared plus 6y. And then leave that gap inside your parentheses to fill in the square. On the x squared, I also need to factor out that negative 1. Any coefficient that's not positive 1 needs to be factored out. So it'll be negative 1 times x squared minus 4x. Leave that gap before closing the parentheses. Now we'll factor each of those squares. For the y variable, we have the center term here, which is 2 times our n number as 6. So the n value is 3, and n squared is 9. 3 squared is 9. So to complete the square, I need to add a 9. That 9 is really a 4 times 9. So to balance it, I'm going to make sure I add 4 times 9 to the other side. On the x right here, that middle value, negative 4 is 2 times our number. I'm going to call it m this time. So our m number must be negative 2. M squared then is 4. So I'm going to add 4. That 4 is really a negative 1 times 4. So I'm going to have a negative 1 times 4 added to the other side to balance it out. When we get factored, we have 4 times. This should factor as the perfect square, y minus 3, quantity squared. 3 times 3 is 9, 3 plus 3 is 6, that checks out. Minus 1 times the perfect square, x minus 2 squared. Negative 2 plus negative 2 is negative 4. Negative 2 times negative 2 is positive 4, that checks out. Equals, let's clear this up. negative 28 plus 4, that was not a 4, 4 times 9 minus 1 times 4, 4. Now that our squares are completed, we want to get this equal to 1, so we're going to divide that 4 off. Everything, or just each individual piece. So they'll reduce here and give me y plus 3 squared minus x minus 2 squared over 4. I don't need to write the 1 in the numerator there. And then equals 1. All right, so to carry this over to the back side of the page, see if I can remember it. I had y plus 3 squared minus x minus 2 squared over 4 equals 1. And I need my center, my vertices, my asymptotes, my foci, all those things. So center first. X coordinate will be 2, shifted to the right 2. Y coordinate, negative 3. Again, it's opposites on both of them since they're both on the same side as their variable. The A value, the value that is underneath the Y, is 1. Square root of 1 is still 1. So A is 1. The B value is going to be 2. B squared here is 4, so the B value is 2. And C then, C squared is equal to 1 squared plus 2 squared. C squared would be equal to 5. So C is the square root of 5. Okay, I can use that to write down the rest of my information. I know that I'm going to have a vertical transverse axis. Because the y variable is the one that is positive. So we're going to be going up for our vertices, this A value, and down. But if I go up 1 and down 1, this will put us at 2, negative 2 if I go up 1, and 2, negative 4 if I go down 1. And then our foci are going to go up and down square root of 5. So 2, negative 3 plus the square root of 5. And 2, negative 3 minus the square root of 5. Those will be my foci. Okay, I need my asymptotes next. So we'll have y plus 3 from the shift that happened in the vertical direction here, y plus 3 equals slope. Remember, that's the number underneath y for rise, number underneath x for run, so 1/2 in this case. Rise 1, run 2, and then x minus 2 for that left-right shift here. If I distribute that, I'm going to have to do the negative of it as well. So I'm going to go ahead and write that one before I forget to mention it. Then I also have the negative 1/2 times the x minus 2 over here as well. So this will be y plus 3 equals 1/2 x minus 1, or y equals 1/2 x minus 4. And this one, distribute the negative 1/2 x. Negative 1/2 times 2 will be a plus 1. So y equals negative 1/2 x minus 2. So these are our asymptotes. All right, I believe that's what I needed. I needed center, vertices, foci, and asymptotes, then draw the graph. I have all the pieces I needed. So our center was at 2, -3. Our vertices were at 2, -2, and 2, -4. And then our foci were somewhere else. So they just have to go up by a square root of 5. So I don't know what that turns out to be, but the y coordinates were -3 plus the square root of 5. So they were at about -0.7. So there's one of them. And the other one just would have had a minus square root of 5 instead. It would have been down at -5.2. So there. All right. So I'm just going to label these F for foci, C for center, and V for vertex, just for myself. Hopefully once I draw the rest of this graph, it'll be easier to tell which these points are. But I want to make sure I can go back and find them. I also know for myself that this is my transverse axis between the two vertices. And my conjugate axis, the axis that is in the other direction, will have a length of 2 in both directions. So it's going to go over 2 in both directions. So this here would be my conjugate axis. It's got a full length of 4 or 2 in each direction. So if I kind of box this shape out, this could allow me to quickly draw my asymptotes. So from corner to corner of my box, I can draw my asymptotes. Personally, I think in this case right here with a slope of -1/2, I can draw those pretty quickly without using the box. And I'm going to do that real quick. So I'm going to say this line right here has -2 as its y-intercept. The slope is -1/2. So I can just count down 2 or down 1 over 2 for the rise over run and draw this here pretty quickly. So just going back to drawing my line for the slope of 1/2. All right, and then I'm going to do the same thing on this one. -4 is the y-intercept. The slope is +1/2. So I can draw my line, watching that slope. There we go. Okay, and it does go right through the corners of your box. So if you have a long enough ruler, of course, you can just connect those corners of your box to draw your asymptote. Okay, now our hyperbola will go through the vertex and then try to curve towards its asymptote. So it's pretty wide. And one of the reasons I could have told or been able to tell from the formula that it was pretty wide rather than narrow is because the denominator under x was larger than the denominator under y. So it was going to have a larger width than it would have a height. Let's check our work. The original equation here, we had ourselves 4y squared minus x squared plus 24y plus 4x plus 28 equals 0. So already I can see that nice wide hyperbola. The center of my hyperbola was supposed to be at 2, -3. Looks like it's in the right spot. The vertices were supposed to be at 2, -2, and 2, -4. Looks like they're in the right spot. And the foci were supposed to be at 2, -3 plus the square root of 5, and 2, -3 minus the square root of 5. So I don't think I typed that all incorrectly. I put it all in the square root. That is not where it's supposed to be. Cut that out. Close the parenthesis there, comma, there they are. Okay, so I apologize. I just typed it incorrectly a minute ago. But we've got our two little points there inside of our hyperbola. And then the asymptote lines, we're at y equals 1/2 x minus 4 and negative 1/2 x minus 2. Let's just make these both dotted so that they are asymptotes. Ooh, and I want a different color than the hyperbola. Nope, different color. I think I said orange. There we go. Okay, so making it bigger, there is our hyperbola with its asymptotes. Nice wide hyperbola. We've positioned all of our stuff in the right place. You can also note that the center is also the intersection point of those two asymptotes. It's right in the middle between everything. Okay, last little topic in this section is how to tell when I'm looking at an equation what type of conic section it is. I could, of course, graph it, but I can tell just from the equation. So if I look at the first equation right here, I am going to notice that there is one variable that is squared, and it's this variable only, right? So y squared is the only variable that is squared. X isn't squared anywhere. If there's only one square, it is a parabola. And because y is the variable that is squared, it's going to be a sideways parabola. So it's going to open sideways along the y, or I think it's going to open parallel to the x-axis is the original phrasing right here. But I'm just going to say sideways because the y variable is squared. So it's going to look like this. I don't know how wide it's going to be. I don't know where its center is going to be. I would need to complete the square in order to find those pieces. But I can tell at least it's a parabola that is sideways. Let's see what I can tell from the others. Here, I have the x variable squared and the y variable squared. And notice how they have the same coefficient. The coefficient is 3 on both of those. So I could divide the 3 off. And this is a circle. So again, how big it is to be determined once I solve it, but it is going to be a circle because they have the same coefficient. In the next one, I also noticed that I have x squared and y squared. I should have mentioned in my circle over here that they were all positives as well, because that's important in terms of being a circle. So this one, they're positives as well, but different numbers. So I have y squared and I have 4x squared. So those numbers being different mean this is going to be an ellipse. If I divide the 16 off of both sides with no number in front of y is going to have the larger denominator, which means it's going to be a vertical ellipse. Okay, so it's going to have the larger y direction. Because y will have the larger denominator, if you imagine dividing the 16 off of both sides, x1's going to reduce, y1 won't, y will have 16 in the bottom, larger in the y direction. Okay, and our last one, again, I do have x squared, y squared, but I've got a negative. And if I have a negative, it's going to be a hyperbola. X variable is positive, so my hyperbola is going to be opening in that direction. It's going to have a horizontal transverse axis. So I can make a quick prediction, at least, of what each of these graphs looks like based on observations of the variables that are squared and their coefficients. If only one variable is squared, it's going to be a parabola. If x is squared, the parabola opens up. If y is squared, the parabola opens to the side. Same coefficients with a positive, it'll be a circle. Different coefficients with a positive, it'll be an ellipse. With a subtraction, doesn't matter if the coefficients are the same or different, it will be a hyperbola either way.